today I will explain the EMF terminal potential difference and the relation between EMF and terminal potential difference. This will be my 7th lecture on current electricity. These are the part of the current electricity. Now, first of all, today I will explain the term EMF. What is EMF? As name, it is EMF is written as electromotive force, but it is not a force, it is an electric potential. Simply it is defined as it is the potential difference between the terminals of the cell when no current is drawn from the cell, or simply we can say when circuit is open. So now let us see here what will be the circuit in this case. Suppose that it is an electrical circuit. Here is resistance R and connected to a cell this with a switch. Now this one is open. Here there is no any flow of current. Here I is 0. So now the potential difference between these two terminals of this cell is now known as EMF, electromotive force, or simply it is potential. Now SI unit of electromotive force will be volt. This simply it is a potential. And also we can say here how we can see a cell in this case. Suppose that it is a cell. Here is two electrodes. Now these are what? Electrolytes, and these are the what? Electrodes. It is cathode and this one is anode. Okay? And the potential difference between these two terminals is known as what? Electromotive force. Now it is a cell. What is cell? Cell is an electrical device which convert chemical energy into electrical energy. Now the symbol of this cell is simply written as like this, and this one is the EMF, and this R is what? Internal resistance of the cell. Also simply we can write, or the symbol will be like this, here E and R. Also we can write like this, and this is the symbol for cell. Now simply it is the symbol of what? Cell. Here is E for EMF of the cell and R for internal resistance of the cell, and here also we can write like this. Also what we can write here, we have some concept regarding this. Now in the case of terminal potential difference, what is terminal potential difference? It is also the potential difference of the two terminals of the cell when current is drawn from the cell, or simply we can say when circuit is closed, as shown in the figure here. Here simply it is an external resistance R, and this one is the cell of EMF E, and this is closed here, positive and negative. Now in this case, this E is now written as here V, and this V will be what? Terminal potential difference of the cell. Here current is I, here current is I, and here the potential difference will be V. This V and V will be same. Also we can say the terminal potential difference is the potential difference of the two terminal of the external this circuit. Also we can say here current is not equal to 0, and here is closed. Here is closed. It is closed circuit. Now how we can express it in terms of the electrolytic cell? Like this here, if it is electrode here these are the two electrodes, and these represents electrolytes, electrolyte. Here this will be positive terminal, this will be negative terminal, and this show what? The external circuit. It is the R. This one is the what? External circuit. Here current is flowing from what? This positive terminal to negative terminal, and current is flowing outside the cell from positive terminal to negative terminal, but inside the cell it moves from what? Negative terminal to positive terminal. So in this case, electrolytes offered some resistance, and that resistance is known as internal resistance, as I discussed earlier in the symbolic representation. This is the EMF, and this one is the what? Internal resistance of the cell, and this internal resistance is offered by this electrolytic cell. Here we will see the relation between terminal potential difference and EMF. What will be the relation? So now suppose that it is a circuit and it is an external resistance R, and now connected to a cell with internal resistance small r. Here is V, and you can say it is EMF, initial value of this one I. Here I will generate, here will be the potential difference across this R. And so what will be the relation between the terminal potential difference and EMF? Simply net current formula, we will use net current equal to net EMF by net resistance of this circuit. So net current is what here? I. Here will be net EMF is simply E, and net resistance, this R and this small r in series. You remember here this capital R and this R will be in series. So R plus small r. Now cross multiplication, it will be I into R plus small r barabar E. So also we can write here E barabar IR plus I into small r. Now here E will be this V from Ohm's law, V equal to IR plus IR. Simply we can find here V equal to E minus IR, and here this is terminal potential difference. This one is EMF, this one is current, electric current, and this one is the internal resistance of the cell, and this is the required relation between the terminal potential difference and EMF of a cell. From here also you remember this net current is, we will use here the concept net current is net EMF by net resistance, or you remember here net EMF is initial value of the cell E, and net resistance this external resistance, and this is the internal resistance. This always will be in series combination. So in this way we can obtain the required relation V equal to E minus IR. This is the relation. So now you remember here EMF and potential, terminal potential, these two are simply a potential. So SI unit or nature will be same. SI unit will be volt here also. So now from this formula we can find the expression for internal resistance, expression for small r of the cell. Simply we can use this equation here, V equal to E minus IR, or this will be also we can write here E minus V, here internal resistance E minus V by I. From Ohm's law also we know that here since V equal to IR, so I will be what? V by R. So this equation will turn into small r E minus V by what will be I, in place of I we can put V by R. So again this formula will be here, this formula here will be small r equal to E minus V by V into capital R, and this is the required relation for internal resistance of the cell. Now we will explain some basic concept related to it, that is for EMF and terminal potential difference, for which we can solve easily the 1 marks question or 2 marks question and of the board examinations. We see here we have the expression V equal to E minus IR. In this case, this equation is valid for discharging of the cell. डिस्चार्जिंग ऑफ द सेल हम लोग जानते हैं कि वो ईएमएफ धीरे धीरे लूज करता है जब डिस्चार्ज होता है सेल, ठीक ना। और यहाँ पर इस केस में हम लोग ऑलवेज याद रखेंगे कि इन दिस केस हियर V इज लेस देन E. V इज लेस द टर्मिनल वोल्टेज ऑलवेज क्या होगा, ईएमएफ से कम होगा। लेकिन जब चार्जिंग होता है तो इन केस ऑफ चार्जिंग what will be V equal to E minus I into R, in the case of charging, क्योंकि चार्जिंग के केस में करंट जो होता है, जो सेल जो होता है, ये मान लेते हैं कि ये हमारा सेल है ना, ये हमारा सेल है। तो चार्जिंग के केस में जो एक्सटर्नल सोर्स होता है वो पॉजिटिव को पॉजिटिव से कनेक्ट होता है और नेगेटिव टू नेगेटिव कनेक्ट होता है, इसलिए करंट जस्ट प्रीवियस के रिवर्स मूव करता है, इसलिए करंट का यहाँ सिंबल जो दिए हम लोग वो माइनस आई दे दिए। सो हियर व्हाट विल बी माइनस ई माइनस इंटू माइनस व्हाट विल बी प्लस इंटू आई आर। यानी इन दिस केस चार्जिंग के केस में जब सेल चार्ज होता है उस केस में हमारा ये क्या हो जाएगा, चार्जिंग के केस में कि V विल बी ग्रेटर देन E, V विल बी ग्रेटर देन E. So you remember these 2 points is very important for 1 marks. And also what we have now further discussion in third point, if I will be 0 means no current is drawn from the cell, then this equation 1, then from 1 what will be V बराबर E minus I 0 into R and V will be E. यानी किस केस में हमारा टर्मिनल पोटेंशियल EMF के बराबर होगा, when circuit is open. Now another is what, in fourth one, when cell is ideal, that is small, ideal cell किसको कहेंगे, the cell having no internal resistance, that is 0, known as what, ideal cell. In this case from 1 what we can write, V equal to E minus I into 0. So again this will be equal to what, V equal to E. Now also last we have what, we have very simple graph कि when we take a graph EMF versus capital R, then this will be like this. Means it indicates that the EMF of a cell is independent of external resistance. Now also we have कि when cells are connected, next point, when cells are connected in this way of EMF E1 and E2, then these are known as in same order. Then effective EMF in this case will be simply E1 plus E2. You remember कि if the cells are connected like this, then the effective EMF will be E1 plus E2. Now again, if in next case, if cells are connected like this, E1 and E2, now it is not in this type of connection. So in this case, the net EMF will be E1 minus E2 if E1 is greater than E2, or E2 minus E1 when if E2 is greater than E1. And this will be also same for this case, when positive terminals are connected like this, then again we can use this formula, these two formulas we can use here. So now these are the basic concept about the EMF and the cell and the terminal potential difference and the relation I discussed here. And so in next episode I will discuss the more concept about the current electricity. So Please like it and share it and subscribe. Thank you.